So we have, this is the third day of coding, so we have this question in the list. It is the third question, 26, LeetCode, remove duplicates from sorted array. And this is the first time I'm solving it, as our subscribers have asked. It may be a lengthy video, it may be boring or interesting, I'm not sure yet. So let's get started. Let's read the description. Actually, when you are solving in an interview, you need to solve easy questions, or actually, like when you get an interview question, you will have 45 minutes to solve. Spend like 5 minutes to understand the question, and the next 5 to come up with edge cases, constraints, or output input cases, your logic. So you need to fit the solution within that time. Let's try. Now is 2:10 p.m. Given an integer array num sorted in a non-decreasing order, remove the duplicates in place such that each unique element appears only once. The relative order of the elements should be kept the same. Then return the number of unique elements in nums. Consider the number of unique elements of nums to be k to get accepted. You need to do the following. Change the array nums so that the first k elements of nums contain the unique elements in the order they were present in nums initially. The remaining elements of nums are not important, as well as the size of the nums. Return k. This actually looks like the question we got at day 2 or 1, which was like let me remember what was the question. It was very similar. Okay, it actually very similar approach. It is giving us the nums list. So we have the list, and we have to change the list in place without requiring any other data structure, like space if possible. And also we need to return k. So yeah, let's paraphrase the question in our own words. Like when you are given a question, like I said, try to make sure that you understand it. I would have asked like, so I'll be given an array. Input is an array, and output should be a number. And how it's checked is like the number would represent, for example, first k numbers, 3, 4, 5, and if the number is like, let's say we had other values here, anything it can be, and if the k was like 5, it means the first 5 elements of the array are not duplicates, like are the value you're looking for. This actually could have been something like 1, 1, 2, 3, 4, and 4. This could have been like this, actually, the list. So they removed this one of the duplicate 1 and duplicate 4 to the end. Maybe these values does not matter, because the algorithm is only checking the solution. When we provide it, they're only checking for the first 5 elements. That's how it's gonna work. Okay, so we have some input cases, and what are the constraints? What do you think? What can be the constraints? What if we are given an empty array? What do? I believe we return a empty list, but it says we won't be given an empty array in the constraints. Okay, and the elements inside the array can be between -100 and +100. And one thing to note is that this array that we are given is in ascending order. It's actually non-decreasing order, meaning that every element is followed by some element that's equal to or greater than itself. increasing order. Okay, let me write some test cases. I will copy paste the first two ones and try to understand it. So here we had duplicate 1. This one is moved to the back or removed so that first two elements are 1 and 2 only. The output is 2, meaning that look at the first two elements. Okay, the next one, output and input. We have this. We have duplicate 0, duplicate 1, duplicate 1. We should remove this and this and this. So when we remove all the duplicates, we will have only 5 values remaining and we will return 5. Okay, that makes sense. Okay, if we get 1 input, we will just return that input because there are no duplicates at all, and the count will be just 1. Just 1. Okay. Okay, brute force solution. The first thing that comes to my mind would be going through the list and deleting each value when I find a duplicate. How? Let me explain. Root through the list, delete duplicate. But how do I find the duplicates? For finding a duplicate, I will need one value which says like your current or previous. I would need when I'm looping through, I will be looking at the current value, let's say, and I will also need one variable which stores a previous value every time we go through values, like it, so that I can just compare and say like, yeah, we had this value previously and it's a duplicate. For that, let's say our okay, let me just show visually the thought process I want to follow. Okay, this one is my current, this one is my previous. At first, they will both point at the same value, and once we try to loop through the list, we will be changing it one by one. Let's say first we loop through 0, and then we say our previous was 0 and move to the next value, and now we check our previous and the current one are the same, so we can do an action like splice, delete from the middle of the array, because array size doesn't matter at all, but that would take a lot of extra time complexity, so it's not like big O of 1. Deleting from the middle of the array can be big O of n actually. So what I would like to do would be just maybe let me just think about it right now. Okay, am I having that one? What about we have a third pointer? Let's think about it. What if we have a third pointer? These 2 pointers are enough to give us the solution, like to tell us that it's a duplicate. We want to move until it's not a duplicate. We don't actually need a third one. Yeah, we keep moving until our previous is not equal to our current. And when that happens, what we can do is to say like, we know this index, this is 0 index, we say index 1, like next index should actually be this value, index 1 of this application array. Will that work? Let's try. Yep, at right here, and we want something like this at this stage. 0, 1. The next one will stay. These ones will stay. 2, 2, 3, 3, 4. we are basically okay, let me just adjust format. We are basically telling, when we reach this 1, we are basically telling this 0, oh, the first index, your next value should actually be 1, because it's not equal. When it is equal, we are just looping. When we swap, like we are putting this 1 here, at that stage, we want to move both of our counters by 1 again. Like the previous will become this one and the current will be this one, and they are the same, so we keep moving until we find a value that's not matching. So we find 2 and 1, they are not equal, so I would say your next value should be 2 depending on the index, and I will move both of them by 1. And here I check, yep, they are equal, so we move. And 3, they are not equal. I would again say, like the previous icon, the next one should actually be this 3, and move. I just moved, like next item should be 3, then I move, and I move this first pointer and check. Like this is our loop actually, we are looping through, this is not a pointer. And then I will loop like to the next iteration. The value is not the same, so I will put 4 here, move both of them, and now I am out of the loop. At this stage, my IDX is pointing to 4. Okay, so it's pointing to 4. Its value will be 3. I should return this IDX plus 1 to give, let's say, previous plus 1 to give the correct answer, which will be 4. Okay, which will be 3 plus 1 in our instance, and 4. Okay. Will it work with a list where there are no duplicates? Let's just check. We will take our pointers, our list, and update it. Here, let's say we don't have any duplicates. I'm removing duplicates. And this one's, yep. And then let's take this list. We have this list initially. We have our first pointer null. Actually, we don't need to initialize it. Our current will be 0 when our current is actually not equal to null. So we let me think, like when it's not equal. Okay, so when it is not equal at the start, no, we can, so thinking, so we can both say like both of them are 0 instead of setting it null. Both of them are 0 works fine. Better option, because when both of them are 0, pointing to 0, and they are equal, we are just gonna move our current, and we are not touching our previous when values are equal. So yeah, that case is covered. And when we see 1, and when we see 1 is not equal to 0, we say the next value should be 1. So we are just reassigning it. And we move both of the pointers by 1. And we see 1 and 2 are not equal. We say like next value should be 2. We are reassigning, but that's okay. It's working. The next time we see 3, we say next value should be 3 because they're not equal. We reassign. And 4, we say we reassign again. We are reassigning it basically, but we move our pointers. It is outside. We stopped our loop. We have our second previous actually pointer pointing to 3, 0, 1, pointing to 4. And here as well, it was pointing to 4. I miscalculated it. It was 3, like 0 index, 1, 2, 3. and it is like index 4, but we will return 4 plus 1, which is 5. It also works. And what if we had just one value inside our list? We have this pointing to 0, both of them are pointing to 0. Okay, we try to loop. Actually, there are no values, there is only 0. And when we finish looping, both of them point to 0, and we will return 1 because we are returning previous plus 1, and that should work. That makes sense to me. At this stage of the interview, I would like to ask, can I start coding? Or is there any edge cases I'm missing? I will think about them, but I don't see any cases that I cannot cover with this example, at least right now. So I will just start coding my solution. Okay, let's not remove it. Loop through the list, and here initialize prev pointer, loop through the list. If prev equals to current, move current. If prev not equal to current, if it's not equal to current, we do two actions right here. We say prev plus 1, it's actually array, prev plus 1 item would be current, and move both pointers. We move both of the pointers. That's what we did. So at the end we return previous plus 1. That should work. That's my okay, that's actually my code, pseudocode. I like to put my pseudocode actually like this when I'm coding, and do everything like step by step according to the pseudocode. That makes sure that I'm not missing out any cases I discovered earlier. Yeah, the thought process. Okay, we have an initializer prev. I will just say prev and equal to 0. Loop through the list, which will be like for do I need the index of the first pointer? When I'm pointing to it, I don't need the index, so I will just use for let num in nums iterator, which does not give me any index of the current item we are going through, but it will just give the current item. Very similar one exists in Python. Okay, so it gives me a number every time. It gives me 1, 2, 3, and 2, 3, 4, 4, 5. Okay, we have this condition inside our for loop. We check if previous equals to current. For actually, when we say previous, we say it is nums prev, because previous is just an IDX. Let me just say, make it clear, this is an index. This is not the actual value of the previous. Let me write my if statement. If nums previous IDX equals to num, which is our current. Actually, as a current is our num we are iterating through right now. Why is it sad? Because of this? No. We want to check nums previous IDX and num. I'm not sure why it is sad. Okay, let's just keep for now. Okay, if they are the same, if the value is the same, meaning that they are the duplicate, or we are at the start of the array we are pointing to the same, we just want to continue. Oh, actually, yep, here I worked with, when I say continue, it will go to the next number. But let's just keep it simple. Let's actually use indexes. Index equals to 0, I less than nums dot length, I plus plus, and I will say let current equals to nums I. So we will have everything consistently. We have this current, and we have, I can just here, to make it clear, say previous equals to nums prev idx. That makes it much more simple and easier to understand. And we can check previous and current. If they are the same, we want to increment I plus plus, or we want to go continue, which will force our loop to continue to the next iteration. Both of them are the same. No, actually, both of them are not same, because if I say I plus plus here for the next loop, we may skip one. Like instead of going to the next value, we may skip by 2. When we are at 1, we go to 3. It may work like that. Okay. Okay. Next value. Next if statement. Oops. Let me remove it. If previous are not the same, we want to move both of them. We have this else statement. Okay, when we are doing continue, actually we don't have to do anything. We can just check for when they are not the same in the if statement and else statement. This statement will not even fall through this, and we will just continue our iteration to the next loop. If previous is not, so then we want to do this, move both pointers and assign. What we would say is nums previous id x plus 1 should be current value, and please move both pointers, which means let's move prev idx by 1, and the loop I that we have will move automatically because of the loop. This is what we want right here. And this one, else, and if they are equal, just move current. That makes sense. I can just remove these nodes for now. I believe it makes okay, it makes sense without them. We have previous idx, and we are not returning number. Yeah, we should add this. It's actually okay, we can just say idx plus 1, and that makes sense. Now let's go through the code with some of our examples. Let's take the first example. We have 1, 1, and 2. When going through the examples, what I like to do is like I try to make these comments in one line. So it will be very clear what's going on and where. Okay, right here we have previous value at 0. Let me also write the case. We have 1, 1, and 2. Okay, we are looping through the I loop. Our I is 0, and our previous value is the number at the 0 index, which is 1 at this stage, and our current is also 1. Are they equal? They are not. Are they not equal? I mean, this statement returns false. We skip. We go to the next iteration. Now our previous, we didn't touch it. It's still 0, but it's our I, like current IDX is 1. Previous number is still 1, and the current one is 1. But this time we are looking at the second one with current, and our previous is pointing to the first one in the array. And we check if they are not equal. Yeah, are they not equal? No, it also returns false. So we just skip, and we didn't touch our previous. Our current is 2. We are pointing at this second index, 2 index. Previous is 1. Current becomes 2, and they are not same. So this is true. And what we want to do, we want to say nums previous IDX plus 1, which equals to this first IDX. Let's set it to 2. And our previous IDX should be incremented to 1. Next iteration, I becomes 3. 3 is actually not less than num's length, so we don't iterate. We end the loop. And here we return our previous was 1, 1 plus 1, which is 2. That's the expected result. We can also use this the same for, let's try to run like the second array. I hope it works. So we have this and our IDX at 0, all of them pointing to 0. And the values are actually 0 as well, as you can see. And that's false. They are equal. This statement is not met. False. We move our current by here. Still false. The same things. And when we reach 1, our previous is still at 0 index. Current is actually at second index when we reach 1, and the value is 0 and value is 1 here. They are not equal. This is true. We increment our we change our nums, say there should be 1, and we increment previous and we move on. Now our current IDX is 3 and previous value is 1, like the index 1 pointing to this 1. Current is still 1, and this one becomes false. The same thing happens when we go to the list fourth index 4, which is like 4 index here, and when we reach 5th index right here, this condition becomes true because our current will become 2 and this previous will become 1. If you can I hope you understand. And then when they are not equal, we come here, we say previous index was 1, 1 plus 1 second index should be actually 2. We update it like this. We move our cursor to second index pointing to here and keep moving. And then when we reach 3, the same thing happens again. We update our array. I hope it I believe it works. Oh, one more thing we didn't discuss is time complexities. I should have done it actually while giving the brute force, like while talking about my solution. Space complexity, space and time complexity. Time complexity is big O of n, because we are given an array and we are only looping through the array once. That's why like it's big O of n. For space complexity, we have this pointers, three variables, but no matter like how big the size of the array we are given is, we will always have these 3 pointers which will just store one value integer at a time, 3 integers, let's say. So it's big O of n, big O of 1, I mean, constant. it's not changing, increasing when we change the nums length. So basically I think that should work. Let's try to run the question. Yeah, test case is passed. Let's submit. Okay, this passed. So it took me around 30 minutes to solve this question with explanation. Okay, yeah, I hope it was useful. This was my first try. I would be doing the same during the interview. Yeah, thank you for watching. Keep coding, subscribe, bye.